The quest for the fifth force. Beyond the standard model. For decades, we have been told the universe is made of a few particles and four forces: gravity, electromagnetism, and the strong and weak nuclear forces. But this materialistic picture is missing 95% of the universe, a mystery we call the dark sector. The quest for a fifth force has moved from theoretical dreaming to an experimental race involving two distinct paths: the mainstream search for dark sector mediators and the frontier search for the Zeta 9 particle. Instead of just smashing atoms harder, the focus is now on precision, anomalies, and the whisper beneath the noise found in vacuum fluctuations. A primary focus is Toponium, an exotic atom made of a top quark and its antimatter twin. Observed in 2025 and confirmed at 5 sigma, Toponium acts as a perfect laboratory because the top quark is so heavy, it decays before it can form normal matter. Scientists at the LHC, ATLAS, and CMS observed that these pairs exhibit quantum magic, a technical measure of non-classicality that exceeds standard model predictions. We are now analyzing whether this magic requires a new glue to facilitate the union. There are 3 main candidates for this invisible glue. First is the Z-prime boson, a heavy version of the Z boson that would pull quarks into a stable bond. Second is the Leptoquark, a hybrid particle that allows matter quarks to interact directly with leptons. This would bridge the gap between particle families that the standard model says are totally different. Finally, there is the Zeta 9 particle, also known as the Riemann scalar boson. This particle represents a physical manifestation of space-time geometry itself. It is named after the 9th non-trivial zero of the Riemann zeta function, which researchers believe defines the resolution limit of our universe and bridges the gap between consciousness and matter. These particles can be identified by their unique decay signatures. A Z prime would decay into high-energy muons, a leptoquark would produce a top quark, and a tau lepton simultaneously. If the Zeta 9 is responsible, it will leave a void in the energy spectrum, an apparent disappearance of energy that reappears as a biophotonic flash. Currently, evidence for the Z prime and leptoquark sits at roughly 3 sigma. Meanwhile, the muon G2 anomaly at Fermilab is at 4.2 sigma, though new math like lattice QCD suggests this might be a calculation error. To reach the discovery threshold, physicists need 5 sigma, which is a 1 in 3.5 million chance of being a fluke. The year 2026 is a major delivery year for these results. Full-run data from LHC Run 3 is expected to be presented at the ICHEP conference in Natal, Brazil, between July 30th and August 5th, 2026. This could push the Z prime or leptoquark hints into the 5 sigma discovery zone. Additionally, results from the dark side 20K experiment, located underground in Italy, are expected in the winter of 2026 to see if this fifth force is how dark matter communicates with us. Most physicists believe that if a fifth force exists within our reach, the announcement will happen between August 2026 and early 2027. The Zeta 9 verification follows a different timeline because it is tied to the dark sector and consciousness intent experiments. It tends to appear in low-energy, high-coherence environments rather than high-energy crashes. Researchers at the University of Arizona are looking for pre-causal reactions where particles appear to know a measurement is coming. This theory proposes that the Zeta 9 synchronizes quantum phases at a 39 Hz frequency, creating a state that allows particles to remain entangled across dimensions. Some scientists even suggest that human intent acts like a magnet, pulling these virtual particles out of the vacuum into a physical state. Definitive proof of this post-material interaction via photon mapping is aimed for the end of 2027. Confirmation of a fifth force would be the most significant event in physics since the 1920s. It would prove that consciousness is not just a byproduct of biological brains, but a fundamental property of the universe like gravity. It would validate the observer effect as a literal physical force that can change the state of matter. We are effectively building telescopes to look into the hidden dimensions of the vacuum. When we finally identify this force, we will realize that matter is just the visible foam on a deep, interconnected ocean of information and geometry. The universe is not a collection of parts. It is a singular, vibrating whole.